Welcome to this fifth lecture of digital image processing. In this lecture, we will see the next module of MATLAB, and that is about basic arithmetic operations. So we will see the basic arithmetic operations among scalar values, or the operations among scalar matrices and vectors, as well as the basic arithmetic operations among vectors or matrices. So first of all, let's start by simple basic arithmetic operations among scalar values. So MATLAB support all scalar operations like plus, minus, multiplication, division. Okay, you can use these operations between scalar values, and there is something maybe new for you, as it's a special feature of MATLAB, and this is backward division. Okay, so 3 backward division 9 is just like 9 divided by 3. Okay, so that's why the answer is 3. So there are two division operators in MATLAB. First one was the simple division, that is the forward division, and the next is backward division. Okay, so and this is operator about the power, so you can use the combination of these operators within expression, and you can use any length of expression within MATLAB. Okay. Okay, whenever you type something on command window, it goes into the command window's history, and you can recall your earlier typed commands from history. Okay, for example, in this case, if I recall the last command, clear all, so I just clear all operations here in command window and just type this new value. Okay, and you can see here, as I have written semicolon at the end of this expression, so that's why its value is calculated and the answer is saved in the workspace, but this answer is not displaying here because we have given the semicolon at the end of this command. Okay, now if we do not give the semicolon at the end, then in addition to the value saved in workspace, this value will also be displayed on Windows the command window. Okay, now we will see the operations, basic arithmetic operations between scalar and matrices, or between scalar values and vectors. For example, here A is a one-dimensional array, or just you can say a row vector having 1 row and 3 columns. So you can use A plus 1, although 1 is a scalar value, A is a vector, but MATLAB allow this operation. Okay, so in this case it's simply adding 1 in each element of A. Okay, so 1 plus 1 is 2, and 1 plus 2 is 3, 1 plus 3 is 4, so the answer is 2, 3, 4. Similarly, you can multiply between a vector and scalar value. Okay, so you can see here a vector is going to be divided by value 2, and here we have written a dot slash 2. When dot is attached with any operation, then it means the element wise operation. Okay, so in this case, because already when we are dividing some vector, with some scalar value, it's just like the element wise operation, so that's why the answer of these two commands is same. Okay, for example here the a's value is 1 2 3, and after dividing by 2, its value is 0 0.5 1 and 1.5. okay, so it means that 2 is going to be divided with each element of a, so it's just like the element wise division. Okay, so that's why here when we have given the command a dot slash 2, so it means we want to apply this division operation element wise with each value of a. Okay, so that's why the answer in this case is same. So you can try multiple operations here. For example, here a dot multiplied by 3 means we want to multiply each element of a with 3. So a's value is 1 2 3, so after multiplication with 3, each value is multiplication with 3, it will become 3 6 and 9. And you can also try this power operation here. So it simply means a power 2 means a multiplied by a, so two vectors are going to be multiplied. Because this is a row vector, it's not a square matrix, so in case of square matrix this command will work, but in this case this will not work because of not correct dimensions for multiplication. Okay, you can see here these both are same commands. You want to get the power you want to get the square of a, or it's just like a is multiplied by a. Okay, you can try multiple commands for values for operations between a matrix and a scalar values, or you can say a vector and the scalar values. Okay. For example, look here, this is a square matrix A, 3 by 3 matrix, and we want to get the square of this matrix. So by here square means a is multiplied by a. Okay, so the answer is this one. But if you put here a dot power 2, then it means you want to get the square of each element of this matrix. So it means one square is 1, 2 square is 4, 3 square is 9, and so on. So you can see here the result is different. Okay, by putting dot here, because here a power 2 means a is multiplied by a, and here a dot power 2 means each element of a is going to be multiplied, is going to be squared. Okay, so this was the element wise operation with the help of dot. Okay, here we try another operations between matrices or between vectors and matrices. So now the scalar values will not be involved. Okay, so for example, consider this square matrix B, 2 by 2 matrix, 5 6 7 8, having this matrix has 2 rows and 2 columns. Okay, so if you are going to perform multiple operations here, so depending upon the dimensions of matrices agree for those operations, these operations will work. Okay, for example, this one is A, this one is B, so of course both have the same order, so you can add A plus B. This is a perfect operation, and it will be again a square matrix of 2 by 2, and you can get the square of this matrix. By square means you want to multiply this matrix with itself, okay, and then it's just like this one, and you can see here you get the same answer, okay. And similarly, here is a A is a matrix, and if you want to check this command, a plus 2 multiplied by 3, so it means it will follow the same rules of precedence and associativity. So it means first multiplication will be done. So here the scalar values are 2 multiplied by 3, so it means a plus 6, okay. So a plus 6 means you want to add 6 in each element of a. So this one be this value will be 1 plus 6 7, 2 plus 6 8, 3 plus 6 9, and 4 plus 6 10. So the answer is 7 8 9 10. Okay, and you can see here a plus 2 plus 3 power 2 means first of all parenthesis will be solved. So 5 raised to power 2 25, so you want to add 25 in each element of a, okay. So this one is a 1 2 3 4, it will become 26 27 28 and 29. And similarly here consider these two matrices, square matrices, a of order 2 by 2 and b of order 2 by 2. You can add these two matrices. If you get the higher dimension square matrices like this one, 3 by 3 square matrix, and this one b is also 3 by 3 square matrix, you can subtract, multiply, and can perform multiple operations on it. B multiplied by a. So now look here on another example. A is a row vector having 1 row and 3 columns, and B is a you can say a matrix having 3 rows and 2 columns. And if you want to perform this operation, a multiplied by b, it is perfectly alright, because this multiplication can be possible because the dimensions of both matrices agree upon it. But when you want to do the this multiplication operation in another way, like b multiplied by a, then in that case, because the matrix dimensions do not agree, this will not work. So you can try other things like you can get the transpose of b, and after that if you multiply a with this transpose, you can multiply it. So for getting transpose in MATLAB, you have to put comma, or you can say a prime on some variable showing some matrix, okay, like this one. B is a matrix, and b prime means transpose of b, so the rows of b will become the columns of b, okay, in transpose of that matrix. Okay, you can see here you can also divide matrices, like here a divided by b, answer is this one. By division of matrices means in fact you want to multiply a with inverse of b, okay. So this operation is just like this one, a multiplied by inverse of b. For getting inverse of a matrix, you have this built-in function in MATLAB, okay. So a multiplied by inverse of b is just same as a divided by b, okay. You can see here the same result we will get after applying these two commands. Okay, there is another thing, as I told you, that backward division is also possible in MATLAB. So if we try this division for the matrices like the case here, then it's just like b divided by a. Okay, so here is a mathematical property if b is an invertible square matrix. So first of all, b should be a square matrix and we can get the inverse of it. Okay, so in that case, a divided by b, here the normal forward division is going on. Okay, so in that case, x into b is equal to a is the solution of linear equation. Okay, so look here, this b is a square matrix and it's also invertible square matrix. So when you do this manipulation, x is equal to a divided by b, and you try to check the this property, then you multiply x with b, then you will get 1 2 3 4. That's in fact a. So this property satisfy here, means x multiplied by b is equal to a. This one is a. You can see here the same result. Okay, and similarly in case of backward division, so it's just like it's not a divided by b, it's just like b divided by a. So it means a is below b. So on the if you want to see it as a solution of a linear equation, then that equation will be ax is equal to b. Okay, because here a backward division with b, so it means a into x is equal to b. So we will see here whether this property follow here or not. Here b is again a square matrix of 2 by 2 dimension, and here we get the answer of x by a backward division with b, we get this answer, and after that we try a into x. Okay, a into x, and we get 5 6 7 8, which is b. Okay, so this property satisfy here. And now look here, because b is a row vector now, it's not a square matrix, so here such property will not satisfy, because the condition for satisfaction of this property is the b should be an invertible square matrix. So here the b is not invertible square matrix. So in that case, if we do backward division of a with b, and we give the answer to x, and after that we multiply this x with b, and we get some answer, and that answer is not equal to a. Okay, here a is 1 2 3 4, whereas it is in 1 2 2.2 and 4.4, so it's not same. Okay, so the reason is b is not invertible square matrix. Okay, so we have noted another thing here, that x answer is in some 4-digit precision. If we want to increase this precision, then we can change the format. By default the format is short, but if we change the format with this command format long, then it means next time whenever we do some operation, then the answer will be in more will be with more accuracy. Okay, because the answer will be in format long. Okay, so you can again change this format. You can make it short or long. By default it is short. Okay, so that's it for today. Thank you.